Okay, this is question 8 on page 72 of section 5.2, dealing with surface areas of prisms. Well, here's an application of that. I've looked at this question long and hard. There are a number of ways you can answer it. All ways will be correct, I believe. But in order to get the answer that it says at the back of the book, I have to do it a certain way only, and there will be some disagreement about this method. Now, this is question 8, as I said. Andrew's making wooden jewellery boxes in the shape of cuboids, and they have length, width and depth, so these measurements, and each box has a lid, so that's part of the surface area required. Now the wood costs £18.75 for 1 square metre. So far so good, and on average he wastes 10% for each metre square that he uses. That is a difficult statement. Anyway, he varnishes the outside of each box, and you have to presume he's going to varnish the underneath as well when he's made them. A tin of varnish will cover an area of 1.5 metres square, and that tin costs £7.99 to buy. So what's the cost of making each jewellery box? So much information. We've got to start by working out the surface area of the jewellery box. Now if we've got a cuboid, looks a bit like that, say, nothing too flash. Oh, it's terrible drawing. Anyway, it's 20 centimetres, it's quite long, and it goes 15 deep, centimetres that way, and the height, let's put the height across here, 10 centimetres. So I've got a 10 by 20 by 15 centimetre arrangement. Make that stand out a bit. So that's what I've got roughly. Let's do the surface area first. So here we go. Surface area, because that's the wood I need to do, right? Fair enough. Just move over a bit. Hello, can you see me? Good. Surface area. Don't put equals. I'm not going to do it in one step. Basically, I've got a 20 by 15. So I've got 20 by 15. Well, that's the bottom sorted. It's the same at the top as well. So I'm now going to multiply by 2. That gives us something or other. 3,600 centimetres squared. I've got a 20 by 10 at the front, and of course I've got one at the back as well. So double that up, that comes to 400 centimetres squares. I've got this little one here which is a 15 by 10. I've got 15 by 10, I've got 2 of those as well. So that's going to give us 300 centimetres squares of wood altogether. Here's the total surface area. That's going to be 1,300 centimetres squared. So far it's dead easy. None of this is negotiable or controversial in any way. Oh, by the way, just to make this look like a proper 3D affair, there you go, spotless, perfect, couldn't have done it better. Now this is the troublesome part, working out how much I can get out of my metre square of wood. Now you may remember that 1 metre square is going to be 10,000 centimetre squares of wood, because a metre square will be, I don't know, 100 times 100, won't it? So that gives us 10,000 centimetre squares. Again, nothing controversial. Now he's going to waste 10% of this. Okay, so 10% of 10,000 is of course 1,000. Therefore, he uses 9,000. On average, this is the troublesome part, on average he's going to use 9,000 centimetres squared of wood every time he buys a sheet. Sometimes he may not waste up to 10%, he may waste a lot less, which means he could get more boxes of wood for his metre square. That's the trouble. So what I'm going to do is take my 9,000 centimetres squared of wood and divide that by 1,300, because I know that's what it takes to make one piece of wood, one box. That will give me, I've done the calculation earlier, so I'm just going to work from my calculation here. That will give me 6.923 boxes. Now let's just negotiate here. You can't have 0.923 of a box. You either have 6 boxes or you have 7 boxes. Now here's the trouble. If we stick to 6 boxes, the amount of leftover wood will mean that he's not actually wasting 10%, he's wasting a lot more than that. If I bump it up to 7 boxes, then that will be absolutely, that will be over the top. He would have wasted less than 10%. But apparently from this calculation I can't quite get 7 boxes from 1 square metre. So I'm going to have to leave it as it is. So for the sake of the mathematics, I can get, on average, for every square metre of wood, 6.923 boxes out of it. So I'm going to have to run with that. So look, I now need to work out how much he's going to spend on the varnish. Now this 1.5 metre square worth of coverage is actually equal to, let's do it up here, 15,000 centimetre squares of area that can be covered. So what fraction of the 15,000 is the 9,000? Because if I'm going to make 6.923 boxes, then I've completely used all of that 9,000 centimetre square available area, which Andrew claims that he's using and not wasting on average. So here I go. I need this fraction of this tin's coverage, and at a price of £7.99. Okay, I'm not using a whole tin on one of these square metre pieces of wood. I'm using this fraction of the whole tin. Now that comes to £4.79. Now, so I know the wood costs £18.75. I know the varnish costs for 6.923 boxes £4.97. So if I take the total cost and divide by this number of boxes, I should get the cost for each box. So here I go. Total cost is going to be £18.75 plus the £4.79, and then share that out amongst the 6.923 boxes. Actually, let's just call it cost per box, because I've gone and divided by the number of boxes I can make on average. So cost per box. So pick up your calculator, blah de blah de blah. It comes to £3.40 a box, because I've done it earlier. Just thinking about it. Now, I'm not satisfied by that at all. I'm really not. I'd rather just go by the fact that making a whole box is a discrete quantity. So because I can't have 6.923 boxes, I could use just the 6 and say I can make 6 whole boxes guaranteed, and then just divide this by 6 and work out what 6 lots of area would be. It would be 6 times 1,300, which is 7,800. So this would be 7,800 divided by 50. It would be a lot cheaper. So, but then I'll be dividing by 6, so it becomes more expensive per box as opposed to 6.923. But that's the answer at the back of the book. I find it very unsatisfactory because of this average, on average he wastes part. That is complicated. I don't enter into more discussion. Obviously we talk about it in class, then we can talk about the different ways of we could have tackled this problem. But anyway, £3.40 per box on average is what he's going to have to pay to make that, and that's complicated. Right, next question. This one, look. Question 9 then. Natalie has 3 wooden cubes. There they are, 3 wooden cubes. She's made this in DT. I've tried to show you the 3D effect there by drawing in the the other edges that you can't see. And so we have a height of 3, 6 and 10 for each of the cubes. She wants to paint this wonderful shape red, and the tin that she's using will cover an area of 0.5 metres square. Now 0.5 metres square is going to be 5,000 centimetre square of surface area, because a metre square is 10,000 centimetres square, so half a metre will be half as much. Will she have enough paint? We've got to show our working though. That's important. Now let's just work out the surface area of the 3 separate cubes before we stick them together. So the large one's going to be 10 by 10, and I've got 6 faces of the same. That's 600 centimetres square. And this one's going to be 6 times 6, and I've got 6 faces again. That's 216 centimetres square. And the baby one, it's going to be 3 by 3, and I've got 6 faces because it's a cube, and that gives me 6 9s are 54, I think. Altogether, that's 870 centimetres squares of surface. However, if you can see here, for example, that bottom surface of 6 by 6 isn't going to be painted. neither is the surface on the big cube that it's sitting on. So I need to subtract 2 lots of 6 by 6, because number one, I'm not going to paint the bottom of the middle cube, and I'm not going to paint the top of the big cube that's covered by the middle cube. Alright, so I need to get rid of that little bit there. So not to paint, put an eye there, it's a 6 by 6, and I've got one for him and one for the big cube as well, times 2. So you don't paint that, that's going to be 72 centimetres squares, and in the same way this little 3 by 3 sitting on top of the middle cube is not going to be painted, so I'm not going to paint that little patch for the middle cube, and I'm not going to paint that little patch for the small cube either. So I'm not going to paint 3 times 3, the bottom face there. I'm not going to paint it for the little one. I'm not going to paint the areas covered on the medium one as well. So that's going to be a further how much? 18 centimetres squared. So therefore I'm not going to paint 9. Let's have a look, let's check that again. 6 by 6 by 2, 72. 3 3s are 9, times 2 is 18. Therefore I'm not going to do that, am I? Let's just check. That's alright. So we're going to paint 870, take away the 90, and that gives me 780 centimetres squares. Right, is that enough? Oh, right, let's just answer it over here then. Yes, lots of paint available, because 5,000 centimetres square is much greater than the 780 centimetres square needed. Alright, so that question's done, and it's quite sweet, isn't it? Next one looks a little bit strange, but I'm going to have a go anyway. Again, I've not prepped this one at all. I don't usually prep anything, I just get on with it. Now, let's just take a look. This is question 10, the last one on 5.2. The area of the curved surface, that's, I mean the curved surface, right? Not that bit, that's the bottom bit, and that's also got radius r. I mean this part here that you can unravel. So the area of the curved surface of this cylinder is equal to 3 times the area of both the ends added together. Express h in terms of r. Well, that's just one sentence, we've got to do it. Now the curved surface, let's just talk about the curved surface. The curved surface, if you unwrap it, is a cylinder. Now the curved surface obviously has a height of h, but across here, when we wrap this round and to form the curve of the cylinder, this is actually the circumference of the original. So basically this length of the rectangle that's unwrapped is the circumference of that circle there. So it's 2 pi r times h. So the area of the curved part alone is 2 pi RH. Have you got that? Now the area of the bottom part of the circle, you know that, A equals pi r squared, and you know the top part as well, A equals pi r squared. So the surface area of a cylinder is pi r squared plus pi r squared plus that part alone, right? These three things all added up make the surface area of a cylinder. And let's just decode what's going on here. And I think I'll write in blue down here. The area of the curved surface is equal to 3 times the area of both the ends added together. Right, these are the ends added together. They come to pi r squared times 2, and the area of the curved surface is equal to 3 times the area of both the ends adding together. Right, so I'm going to go pi r squared times 2, that's them added together, and it's going to be 3 times, I need to multiply by 3 to make the curved surface. So that is that, so that comes to 6 pi r squared. Let's read it again. The area of the curved surface of this cylinder is equal to 3 times the area of both the ends. The curved surface, in other words, 2 pi r h is equivalent to 6 pi r squared. and it says express h in terms of r. Okay then, so I need to take my h equals 6 pi r squared and divide by 2 pi r. That's to single out the h on its own. Well, what have I got? 6 divided by 2 is 3. The pi's, bless them, will cancel, and I'm left with r squared divided by r, which leaves me r. Therefore h equals 3r, and I'd give that at least the grade B, I would. Alright, so that's it, 5.2 done, and I'll go into the assess and do a few more questions in a minute.